Okay, in this video, we are going to look at how to calculate the pH and pOH of strong acids and strong bases. Before we do this, we should have some concepts. So, strong acids and strong bases, when they are in aqueous solution, they act as strong electrolytes. They act as strong electrolytes. They conduct electricity, and then they ionize completely. They ionize completely. So we are going to use a full arrow for them. Now, if it was a weak acid or a weak base, weak acids are weak electrolytes. So strong acids or bases. Weak acids are what? Weak electrolytes. And then they ionize partially. Weak acids are what? Weak electrolytes. And then they ionize partially in aqueous solution. So we are going to be using reversible arrow or equilibrium sign for them. So what's the meaning of the complete ionization, the partial ionization? The complete ionization means that if I have an acid here, if I have let me use HCl for example, I put it in aqueous medium, it will go completely to H plus aqueous and Cl minus aqueous. So initial, this is my initial. Initially, I had a concentration here, a particular concentration of the acid. Nothing had happened. Then finally, all this went straight here, meaning that this full concentration came to the product side. So everything here is C. Then here becomes 0.00. Because if everything is gone, what is left is C minus C, which is 0. So you have to take note. When you write your equation for the dissociation or the ionization equation for the strong acid, you have to balance it. So here the hydrogen is already balanced. So be careful. This is monoprotic. It has only one hydrogen. So that's why they even focus on the balancing. If it is diprotic or if it is polyprotic, make sure you balance the hydrogen before you proceed. Alright, so now we can calculate this. We already know that pH is equal to negative log of what? Concentration of H plus ions, and pOH equals negative log of concentration of OH minus ions. And we came out with the formula that pH plus pOH equals pKw, which is 14. So let's solve the first question here. Calculate the pH and pH of all this. So these are concentrations. 0.1 molar HCl, 0.1 molar H2SO4. This is sulfuric acid. 0.1 molar sodium hydroxide, 0.1 molar calcium hydroxide. So let's take the first one, I. We first write our equation for the reaction, put it in aqueous media. Strong acid, it will ionize completely. We use full arrow. We get H plus aqueous and we get Cl minus aqueous. So now, here was 0.1, 0.00, 0.00. H plus is balanced. First check if H plus is balanced. It's balanced, so we can continue. So at the end of the reaction, this whole concentration will come here. The mole ratio here is 1:1. So here becomes 0.1. Mole ratio 1:1, 0.1. Here becomes 0.00. So the concentration of H plus, and as you can see, is 0.1. So our pH is going to be negative log of 0.1, which will give us 1. So the pH is 1.0. Now to get a pOH, we know that pH plus pOH equals 14. So our pOH is going to be 14 minus 1.0, and our pOH is going to be 13.0. Alright, so now let's calculate for the second one. 0.1 molar H2SO for the pH and pOH. So we have H2SO4 aqueous complete ionization because it is a strong acid. H plus SO4 2 minus. Now we can see that I have one hydrogen here. We have two hydrogens here, so we must balance and put 2 here. Good. Initial concentration 0.1 molar. Initially, when the reaction was not complete, this is what we had. Now, at the end of the reaction, all these 0.1 will shift here. Mole ratio of here is 1:2, meaning that this one requires twice as much as the concentration here. So it becomes 2 times 0.1. Here is 1:1, so still 0.1. And here becomes 0.00. So concentration of H plus ions here is 0.2 molar. Then our pH is going to be a negative log of what? 0.2, which will give us negative log of 0.2. So this is giving us 0.7. Then we can find our pOH, which will be 14 minus 0.7. And our pOH is going to give us 13.3. So we can go ahead and do the calculation here. So here I just need to write the equation for you. You can find the pOH. So sodium hydroxide aqueous is going to give us Na plus OH minus. So we know everything else. The mole ratio is 1:1. So 0.1, 0.1. So the pH, so to get the pH here we have OH. So you have to find pOH first. Yeah, you have to find pOH first. Negative log of 0.1. When you're done, you subtract from 14, you get the pH. And then for the last one, we have calcium hydroxide aqueous. It will give us Ca2 plus OH minus. You can see that the OH minus is occurring twice. So we must put 2 here, which means 0.1, 0.1 at equilibrium. Here will become 0.2 because it is twice as much as this. Then we can get the pOH to be a negative log of 0.2. When we are done, we subtract from 14 to get the pH. This is how to calculate the pH and pOH of strong acids. In our next video, we'll be looking at how to calculate pH and pOH of weak acids.